Our lesson for today is how to calculate net present value, NPV, and internal rate of return, IRR. Let us first define the meaning of net present value and internal rate of return. The net present value is an investment measure that tells an investor whether the investment is achieving a target yield at a given initial investment. It quantifies the adjustment to the initial investment needed to achieve the target yield, assuming everything else remains the same. Net present value is simply the summation of cash flows for each period in the holding period discounted at the investor's required rate of return. On the other hand, the internal rate of return is the percentage rate earned on each dollar invested for each period it is invested. Another term used for the internal rate of return is the economic rate of return or the discount rate. It gives an investor the means to compare alternative investments based on their yield. Mathematically, the exact internal rate of return can be found by setting the above net present value equation equal to 0 and solving for the rate of return through trial and error. What is the acceptance rule for the net present value and internal rate of return? For the net present value, we can accept the project when the net present value is positive. We may reject the project when the net present value is negative, but we may also accept the project when the net present value is 0, because a positive net present value promises a return greater than the required rate of return, and having a 0 net present value is also acceptable because it promises a return equal to the required rate of return. For the internal rate of return, we may accept the project when the internal rate of return is higher than the discount rate. We may reject the project when the internal rate of return is lower than the discount rate. But we may also accept the project when the internal rate of return is equal to the discount rate. Generally speaking, the higher a project's internal rate of return, the more desirable it is to undertake. So let's have here a project proposal. Goldilocks Bake Shop Incorporated wants to put up another Goldilocks store in United States, and the franchising term is 8 years, with a total investment of $1 million. The objective of Goldilocks Bake Shop Incorporated is to determine the net present value and then the internal rate of return of the said project proposal and interpret the results if it is a good investment or not, having a weighted average cost of capital of 7.59% for United States of America and reinvestment rate of 3%. For step 1, we need to determine the initial cash outflows and projected cash inflows necessary for the investment. For the cash inflow, it could be the reduction of cost or salvage value and incremental revenues. For the cash outflows, it could be the initial investment, operating costs, or the working capital for the said project. For step 2, we need to determine the present value factor using the discount rate, wherein the present value factor is computed as 1 plus r raised to the power of n, wherein r is the discount rate and n is the number of years the cash outflow or inflow will materialize. So for the computation of the discount factor for year 0 to year 8, we can use the formula 1 plus r, which is equal to the cost of capital of 7.59% raised to the power of that particular year. That would give us the discount factor for year 0 to year 8. For step 3, we need to divide the cash outflow and inflows with its corresponding discount factor to get its present value. And then for step 4, for the net present value, we can use the financial formula and input the values for the cost of capital and present value. So, for the cost of capital, we can use 7.59% and input the present values for year 1 to 8. That would give us a net present value of $990,289.68. For step 5, for the internal rate of return, we can use the financial formula and input the necessary present values for year 0 to year 8. And that would give us an internal rate of return of 25.48%. Any project with an internal rate of return greater than its cost of capital is profitable, and thus it is a company's interest to undertake such project. For step 6, we can also compute for the modified internal rate of return by using the financial formula and input the necessary present value, the cost of capital, and reinvestment rate. So we can input the present values for year 0 to 8, the cost of capital of 7.59% and reinvestment rate of 3%. That would give us a modified internal rate of return of 15.29%. So we use a modified internal rate of return so that the discount rate that equates the present value of the project future free cash flows with the terminal value of the cash inflows. Therefore, in assumption that all free cash flows over the life of the project can be reinvested at some interest rate until the termination of the project. For the interpretation of the results, using the 7.59% cost of capital for United States, it will yield a positive net present value. Therefore, we can accept the project. Using the internal rate of return, there is 25.48%. With this rate, internal rate of return is greater than the discount rate. Therefore, we can accept the project. Assuming the cost of investment are equal among the various projects, the project with the highest internal rate of return would probably be considered the best and be undertaken first. But a project may have a low internal rate of return but a high net present value, meaning that the company sees returns on that project may be slow, but the project may also be adding a great deal of overall value to the company. Conversely, a longer project may have a low internal rate of return, but if the earning returns are slow and steady, it may still add a large amount of value to the company over time. On the other hand, using the modified rate of return, there is 15.29%. With this rate, the modified rate of return is greater than the cost of capital. Therefore, we can accept the project. As an investment rule, if the project's modified internal rate of return is greater than or equal to the project's required rate of return or cost of capital, we should accept the project proposal. And that ends our lesson for today about net present value and internal rate of return. Thank you very much. Thank you for listening. This instructional material is prepared by Patrice Caneo and Mary Rose Capistrano.